In this part, we're going to explore the Industruino from the software side. So we're going to look at how to program a firmware for it. This is what we want to do, developing firmware using the Arduino framework for an HTTP JSON REST API. Going to look at the Arduino IDE for a very easy way to program the Industruino with our own code, followed by a step-by-step intro. First, we're going to program the onboard LCD to see how it works, and we're connecting to an Ethernet network. Then we're adding a simple HTTP server so that our Industruino is able to serve HTTP requests. And then we're adding some JSON processing to an HTTP endpoint so that I'm able to send JSON data to the device, and the device is able to process it and answer back with JSON data. And we're not coding all the examples here line by line because that would probably take far too long. All the examples here are already prepared in a GitHub repository, and we're going to look at the code sketches for each of the 4 parts. So let's get started. This is our Industruino, and already connected it using USB, and it shows the pre-flashed demo code from Industruino. So that's the main board, and I have the Ethernet expansion module, and already attached to a DIN rail here, and both modules are connected using this adapter here. So that's how things work, hopefully. It should work with other modules as well from Industruino. We have this here, the PROTO D21G. It should work out as well with the int.io D21G, but be sure to have the most recent version that is indicated by this here D21G, and the Ethernet module. There's an additional module for GSM and GPRS, but we're not going to use this, and sketches probably will not work out with this because this module needs a different library. Okay, so first part is getting started with the Arduino IDE. It's a very good and easy way to program your Arduino devices. You probably know that. If not, go to arduino.cc and download the Arduino IDE for your platform. It has support for the Industruino, or let's put it the other way around. Industruino implemented support within the Arduino IDE for their devices, so that makes it really easy. Okay, let's start with the Arduino IDE. If you open it, it should open a new sketch. The first thing we need to do is to go to the Tools menu and to the Boards section and open the Boards Manager. And we can search here for Industruino, and there it is, Industruino SMD boards, 32 bits Cortex by Industruino, and on my PC it's already installed. You should see an additional button here that lets you choose a version, select the most recent version and hit install, so that will install the board support packages and libraries and stuff that is needed to compile firmware for your device. Okay. As I mentioned before, the demo code that we're going to look at in this tutorial is already at GitHub. Please head to github.com, schmidt75, that is my user account, and the repository name is prototyping-industruino. So it's a sample code repository for the Industruino Proto with the Ethernet module. And the code, or the repository, is organized as a single sketch demo. So it's always the prototyping-industruino.ino, that's the code file, and we have a README and a subdirectory called docs, where there are individual descriptions and markdown files for all the actions in the different steps that we're going to do here. And it's organized in branches, so if you hit on the branch button here, you can see there are 4 branches, and they map to the parts within this tutorial. So first is we're going to look at how to program the LCD, then we're going to connect it to an Ethernet network, add HTTP code, and then add the JSON API processing. Let's start with the LCD code. Switch the branch so that it displays a 1-LCD. And of course, you can clone the whole repository and switch branches on your local copy. Be sure to fetch the repository with branches, with all branches. For this tutorial, I'm just opening the files in the web browser and copy and paste them over to them. That's much simpler. So let's visit prototyping-industruino.ino. That's rather small, so I switch to the raw mode, copy everything over in my Arduino IDE. Go back here. And yeah, let's look at the code. And it starts by including a library for the UC1701, and that's the display, that's the LCD display. Typically, when starting new with Industruino, you probably do not have that library already. So what you can do is go to github.com/Industruino, that's where their code resides, /UC1701, that's the repository. And when you say clone or download, you have the choice to download the whole repository or the master as a zip file. Please do so. And then within the Arduino IDE, go to the menu, to the sketch menu, and say include library, and then you may add a zip library. And you just add the file you just downloaded, and then it should be there. If you do so, it typically will add another line here with a include line. Can erase that, no problem. But then your library should be installed on your local machine. So let's look at the code. What does it do here? First, it's defining a global variable, no, a global static global variable. It's the UC1701, that's the name of the class with all the methods in, and it's named LCD. And we have a constant defined here, pin LCD backlight. So as you can see here, the display has a backlight, and the brightness of this backlight can be controlled with an analog pin. And this is the pin, it's pin 26. So for better readability, I give it a name and use it later on. So we have a setup method, which does some things, and a loop method, which is empty because we just want to demonstrate simple stuff. And then the setup method is sufficient, or setup function. And it starts with turning on a serial USB with the given speed. So that's good for debugging purposes. And then it says LCD.begin, so that sort of starts the display. And we write the value 255 to that LCD backlight pin to turn it on fully. We clear the display, we set the cursor to the top left point, and then we print out Industruino PROTO. And yeah, we didn't use serial USB, should change that. Let's do something like serial USB print ln Industruino PROTO and delay a second. Okay, open the serial monitor, look for the correct speed here. It's the same as here, has to be. And then compile and upload. Oh yeah. Compiles the sketch. And should upload it to the device. You can see it here. It starts to flicker. Then, yeah, we have our LCD displaying Industruino PROTO here. And as we can see on the serial monitor, it prints out the same string every second. That's what we just added here. So the LCD class, that UC1701 class, has a bunch of methods to set the cursor, clear the line, clear the whole display, print out stuff. Also adding new font elements if you want to have some graphics on that screen. But it's very simple class. For our needs, it's totally sufficient. So that was the first step. We can close that now. And yeah, go on to the next part. So we don't need that anymore. And back to our prototyping Industruino repository. We can switch to the second branch, O2_Ethernet. Okay, switch to raw, just copy and paste all of that over into that window. Okay, go back here. Let's make this a bit larger to have a better overview. Oh, that's a bit more code. So what I need to do now is an Ethernet cable and connect it to the Ethernet expansion module here. Okay, let's look at the code. It's grown a bit larger, and we need an additional library here. When programming for Arduino, you can typically include the Ethernet class, and on boards with Ethernet this should work out well. The Industruino brings its own adapted Ethernet class, and for that we're going to look at GitHub again, at their Industruino user, and there is a repository named Ethernet2, and that's what you would need to download as a zip and include to the Arduino IDE as well. So please do so. If you do, typically a bunch of includes will add to the code here. So there's include for SPI, which is needed, and some things which we actually do not need right now. UDP2 client is not really needed. Essentially, I think it's Ethernet 2, and we're going to use DHCP and probably the util class. So what changed? This we know from the last sketch. I'm adding a special character here called glyph, and this is in binary representation, and it's simply a full bar of 5 lines completely, or 5 columns completely filled. And that is code for the display. And the next part is about the Ethernet stuff. So it doesn't carry its own burnt-in MAC address. We can define a MAC address here. So this is one of the freely chosen MAC addresses that you probably find on most Arduino examples that have that sort of stuff. It reads deadbeef feed. Has to be unique on your local network, of course, so change that. It's better to change it to something else. And when starting with the Ethernet attached, I would like to display the IP address and some more info, but not indefinitely, but only for a number of seconds. And that's where this global define here is here. Network info delay seconds 10. I want to display it for 10 seconds. Then the setup method the setup function has grown in size, and it's mostly concerned about displaying network related information. It starts with serial USB, same old. This line is new. It says create character, and we're using that glyph byte array here to have the display create a character and store it at position 0. So when starting the sketch, I clear the display and print connecting in the top left corner. And then I say ethernet.begin and give the MAC address. And by only giving the MAC address and no IP address, it triggers DHCP so that the router sends back a valid IP address for the device to use. That method may return 0, which means that there was some sort of network, a DHCP error, and the device does not have an IP. In that case, we print out an error and print out at least the MAC address so that you'll be able to somehow fix this, maybe at the router level. If it did receive an IP address, then we're printing out the MAC address. In the next line, we're printing out the IP address using ethernet.localIP. We're printing out additionally the subnet mask, gateway IP, and the IP of the DNS server. And when we're waiting for that amount of seconds, 10 seconds as it's defined, and while waiting, we show a simple progress bar by printing that glyph that we just defined at succeeding positions from left to right. So that's a simple progress bar. After that, we'll clear the display, and then stuff can be used for other things. So let's see if that works out. Compile and upload. Take some time to compile the sketch. And it's flashing. It says connecting, and yeah, we have an IP address subnet mask, and you see the progress bar, and it's after the last digits here, 101, and then it clears. So let's see if I can reach that device on the local network. Yes, I can. Works out well. Cool. So we have added Ethernet network connectivity to that device. Great. Let's look at the next step. So we're connected to a network and we want the device to respond to HTTP requests. Let's switch to the third branch, 03_HTTP, and additional code has been added. Let's copy this, copy and paste into the Arduino IDE. Okay, what changed here? I included another library, that's the Arduino HTTP server. Okay, let's take a look at that. It's on GitHub. Quicksender/Arduino HTTP server. It says server-side minimalistic HTTP protocol implementation for the Arduino platform. Great. So this is not a complete HTTP server with everything in that you could imagine. It says, yeah, it's minimalistic, and mainly it offers two classes dealing with HTTP request and HTTP response. And yeah, that's what we're going to start with. Works on all Arduino boards. So for this to work, we're going back to the Arduino IDE and go to Sketch, Include Library, and Manage Libraries. Because this library is known to the Arduino repository, we can directly search for it, and we'll find it here, HTTP server 011 installed. If not, you should be able to select a version here and hit install to get it installed. Please do so. Okay, it includes the header file, and we have some definitions here. Stream request size, that's necessary to be defined, and it reflects the maximum size that HTTP request may have to be understood by this library, because it has to be buffered somewhere in between. And we're defining on what port we would like to our device to listen, and that's port 18, to keep things simple. Okay, LCD stuff, as from the last example. Ethernet stuff, as from the last example, but I refactored setup code into a separate function called it setup networking, but essentially it does the same thing, display IP address and stuff, and show the progress bar if all worked out well. So let's look at more HTTP-like code. So what we do here is declare a new variable, define a new variable from the class Ethernet server, and give it the number of the port. And we have a setup method here, setup HTTP, which starts with server.begin. So it tells our Ethernet server to start listening on that port. At the same time, we position the cursor on the display at the top left and say, okay, HTTP is active. And this setup function is called within the setup function down below. First, we initialize our networking, set up the networking stuff, as we saw in the last example. Then we call setup HTTP, so the server is active. But as of now, we want to listen to new packets that come in, and this we have to do within the loop function. This has to be done continuously, and factor that out into a function called HTTP loop, which we have here. And it works by defining an instance of Ethernet client and assign it to the result of server.available. So whenever something new is available, a new connection, make a client object from that. If that worked out well and the client is connected in the sense of TCP connection, Then we could do some HTTP processing. And how that is done follows here within this block. It starts with a class stream HTTP request from the Arduino HTTP server library. And it's called HTTP request. And it's assigned from the client, from the Ethernet client. So that sits on top on the Ethernet client and becomes a streamed HTTP request. And there's a function read request that tries to read what it can from the Ethernet packet. And if that's a valid HTTP request, then we're lucky, we may process that HTTP request. If for whatever reason this is not a valid HTTP request, we're going to send back an error. And there are reply objects for that. And one is the stream HTTP error reply. And this sort of boilerplate default code: form a reply upon the client connection object, return with the same content type of the request, and send an error description from the request parsing here. Okay, shouldn't happen too often. Normal operation would be, okay, it's a valid HTTP request and we process this request. So that's where the function HTTP process request is for, and it's declared above. HTTP process request. It takes in an instance of Ethernet client and the request object. And we're going to do some debug stuff here. We're asking for the URI by calling getResource2string and store it in some string reference. And then we print out what we have at the second line. We'll clear the line and print out the HTTP method that came with the request, for example, a get method or a put method. In the next line, we print the URI. And if we have some form of HTTP body, so data that comes with the request, we print out that as well. We check using get body from the request, and if this is not null and has a length, then print it out. And we want to send something back, so there's a stream HTTP reply instance, and it just says, okay, we're going to reply with the content type text plain and just send back okay. Okay, let's try this out. Compiling. Okay, it's flashing. Good, so that's the same IP address. Let's open terminal. And try this out. So I'm using curl because it's easily available on my platform. You can use a web browser but only for GET requests. You can program your own or use software such as Postman, or wget is also possible. So I curl to HTTP and the IP address and give some arbitrary URI. Oh no, wrong IP address. It's 101. Yeah, it's sent back okay, and on the display we see, okay, it was a get method and the URI is /some/thing. Now that was the get method. Let's try out the put method as well. So curl, I can take that example, post to the same URI, and I need to say that I want to have the put method, and can also add some data to this. Let's use this here. And we see on the display put method, same URI, and that's the body. What? Great. So we have a very, very simple HTTP server. Yeah, good. So that was the third part, adding very simple very simple HTTP endpoint. So let's advance to the last part. Going back to the repository, prototyping Industruino, and select the fourth branch, JSON API. Okay. Copy and paste all of this over. And should have additional code. Yeah, it does. Great. So we'll have hit the right branch. We're using a library to process JSON, and that's a very, very well-known and popular library. It's called Arduino JSON. It's arduinojson.org, and it's for a whole bunch of platforms. Has really great features and a very good documentation. So it'll be very easy to get into this library. And there's also an online book for learning about the background of programming with Arduino JSON. So this library is known to the Arduino IDE, so we need to go to the Arduino IDE, select Sketch, include library, manage libraries, and then we can search for Arduino JSON. Yeah, and here it is, Arduino JSON version 5.13 installed. So please select the most recent version that you see here, hit install to install this to your local desktop. Okay, let's look at the sketch. What does it do? So that's old stuff. LCD display unchanged. Ethernet all unchanged. And there we have some JSON processing here. It starts by including Arduino JSON.h. And there are a bunch of classes within the Arduino JSON namespace. And we're using a static JSON buffer, very limited size, and we are dealing with JSON objects to be created or parsed. And yeah, that's what we want to achieve in this part. But first, we're going to approach this example from the HTTP side. So we had in the last part already that HTTP process request function, and it just did display what we have as a request. And I refactored that out into a separate function called HTTP display request. That's this one here. And yeah, I want to be able to respond to certain endpoints with certain methods, and that's what I'm going to do here. And this block checks for the method and the URI. So if the method is get and the endpoint, well, at least the first part is example, so for example, slash example, then it calls HTTP JSON get example together with client and the request and returns. And I have the same for put here. And that goes to HTTP JSON put example. And this is the point where you might think, okay, the Arduino HTTP server library is why it's minimalistic. It doesn't offer that sort of routing capabilities. So there's no routes here or no forwards or whatever. You have to just query what you get as a request and act accordingly. And now it's the point where we can look at these functions here. So HTTP JSON get example. That's a bit above here. HTTP JSON get example. It takes the client object and the request object, and it assumes that it has a body. Oh no, that's the wrong example. The put assumes that it receives a body. The get just displays something in JSON. So, and what it displays is composed by the JSON serialize example. And it serializes content in the string, which is then sent back by this reply object. And it has the content type application JSON, and it just sends the string. Now let's look at how the string is composed. Just JSON serialize example. And this is where we construct a buffer. We have to do this, and there's different methods of constructing a buffer. We do this as a static JSON buffer, which means that the buffer is located on the stack and everything here happens on the stack of this local function. And we create from this buffer a JSON object, and we can access values within this JSON object by just accessing them via these array brackets and as a string. So looks like more modern languages, and we set the value of this to some example value, which is a global variable. And then we let Arduino JSON print out the map that we have here in JSON format to the string reference. And the second example is the other way around. We have the JSON put example, which expects to get JSON data as input within the body. So if it does, then we deserialize. Here we are. We deserialize from the body. And if that went out well, we store what we deserialized in our global variable and return back the result. So let's try this out. Upload and sketch. So for brevity, I omitted some details here. For example, if parsing did not go well, then we get to know this by asking the JSON object for success or not, and we can return either true or false if things went out well or not. So if they did not went out good, then we can return back an error. So this flashes here. Okay, it says connecting. Good, let's take the terminal again. And let's curl for the, let's call the example URI. Good, it said get/example, and it returned value of 0, because that's what the example value initially is, 0. Let's try to set this value. So from the poor man's routing here, you can see if we have the put method to /example, then it triggers the put example function. Let's try this out. Now, as data, I have to give JSON, and not arbitrary JSON, but something that it can really parse, and essentially it's the same style as what we have from the GET request here. So I say value 10, and it received the value, and it should have stored the value in its global variable, and it returned back the same thing. So if I again query the /example URI with get, I get back value 10. Great, so we now have a sketch that responds to HTTP requests, has an endpoint that understands JSON. And that's a good basis for writing a REST API. Let's recap. We know how to program the LCD, get debug information or a small UI on it. That's also possible. Can connect to an Ethernet network using our Ethernet module. We have seen how to use the Arduino HTTP server library to add simple HTTP processing. And we've seen how to use Arduino JSON processing to make our endpoints understand JSON. Resources for this part, you can find all of that on the internet. Industruino.com is everything about the products. The demo code we just saw in different branches is in this repository. There's libraries for the UC1701 for the LCD display and the Ethernet 2 library from Industruino. You can find the Arduino HTTP server on GitHub, and Arduino JSON on arduinojson.org. So you maybe, this first example and the code is a bit, has grown large over time, and it's highly repetitive. So when writing a larger REST API on that device, the sketch and the firmware will probably become large, and we can search for new ways to make stuff easier. For example, libraries or other generators. And what's still missing is some form of model for this API. Just because I program /example endpoint with get and put doesn't mean that the next one does it the same way. And how to make devices interoperable by modeling stuff. That's an interesting topic we're going to look at.